Good morning and welcome back to our tooth cutting lecture series where we're going to focus on looking at hand tools that are used for woodworking applications. And I think it's important that we talk a little bit about how as artists or as makers, we're typically starting with an idea. And that idea is often driven by what we call the aesthetic imperative, which is how we need what we're making to ultimately look when we're done. So that often involves making a choice of materials, and that choice of materials is informed by both the mechanical properties of that material, so what it works well for. So a soft wood might be really good for carving, where we might need to use a harder or denser wood material for its resistance to wear or impact. Or it might well be because of the aesthetic properties of that material support the conversation. So say, for example, in the case of liturgical art or religious art, the choice of the material might be based on what the vested meaning or association of that material is. So, for example, in liturgical art or in religious art, in particular in Christianity, oak was often the material that was used. And the reason that oak was used is that the appreciation or the association that people had with oak was one of its connection to gods like Odin that had the ability to throw lightning down onto the earth. And because oak trees were among the tallest trees in Europe where Christianity began, those oak trees were often hit by lightning. And so the thought was that because these were being struck by lightning that they had, some connection to the gods in some way. So that's an example of a context in which the material had a vested meaning or association with it. So anyway, we choose a material for the mechanical or aesthetic properties or the vested meaning of those materials or association that we have with them. And as we get into thinking about the kind of tools that we'll need to manipulate those materials, we often benefit from developing an understanding of the behavioral characteristics of that material and how well suited it is for the project, what the cost of those materials might be, and what the cost of those tools associated with getting the job done might be as well. So several of the tools that we're going to talk about are adaptable to a wide range of different materials through things like the ability to change out or swap blades or adjust the speed or orientation of that tool to the material. And we'll go into some detail about that when we talk about these different saws. Most all of these saws involve the use of teeth that are spaced out in regular intervals, and these teeth are measured in what are called TPI, or teeth per inch. The teeth of the blades are often made of different types of material depending on how hard the material you're cutting is, and the teeth are organized or oriented in what's referred to as a particular set, and the set is has to do with the way that the teeth are positioned in a row in a way that's sensitive to the task that it's designed for. We also have the thickness of the blade and the width of the blade as variables that determine outcome. So narrow widths of a blade allow us to make a tighter turn or radius, where wider widths of a blade like we have here are better for straight cuts through thicker material. So let's step back and sort of talk a little bit about this idea of teeth and the way teeth work. And let's talk about that in relation to working with wood products, right? So, we have teeth, and our teeth are engineered or designed for different applications. We have, we have incisors and canines, and we have molars, and those are designed for different functions, right? So things like canines and incisors are widely spaced and used for tearing things apart, where things like molars are closely spaced and used for grinding up small particles, right? So the shape of the teeth and the spacing of the teeth largely determine how it's going to interact with those materials that we're working with. So let's talk about wood materials in particular. Like this brush, wood products are oriented longitudinally, or the fibers are oriented along the length of that piece of material. So when we cut across the fibers of that material, we refer to this as cross-cutting. When we cut with the length of the fibers, this is referred to as ripping. So when we're ripping stock, the chisel-like edges of the blade can strip out those long fibers. But when we're cross-cutting, we're using teeth that have more like knife-like edges that are able to cut across those fibers without shredding or fraying or tearing them up too much. So we can see in this piece of this pine shim that we can see that those fibers are longitudinal. They're organized along the length of that material, right? And we can see the little edge of those fibers presenting themselves. So that's a good example of the orientation of fibers in a piece of hardwood or softwood. We're also going to often find ourselves working with engineered materials, and engineered materials like plywood have the fibers oriented in opposing directions. So in the top layer, they're facing this direction, the next layer this direction, the next layer this direction. So because the direction of those teeth are alternating and the direction of the fibers are alternating, they behave much more like this cloth, this gauze, which has fibers running in two directions. So again, we benefit from fine teeth moving across a surface like that so that they don't have a tendency to rip or shred or tear out those fibers. And then we have other engineered wood products like particle board or MDF, and that is it's essentially wood dust that's been compressed together or bonded together with an adhesive or a glue that hold those fibers together. So this also behaves differently in that instead of clearing out fibers, it's clearing out small particles. So another important factor when we think about the orientation between the saw and that material is the orientation between that saw blade and those fibers. So if I bring this up on edge with a really coarse blade, it has a tendency to bounce or grab across that edge. But if I lay it down on its side, that puts more teeth in contact with the surface of that material. And it's important to remember that we need a minimum of 2 to 3 teeth in contact with that material to minimize the tearing out of those fibers. So let's look at some of the saws that we have located here on the table, and then we'll go into a detailed demonstration of how they work. So here you can see this big monster ripping saw has widely spaced teeth. Those widely spaced teeth have these valleys in between them. Those valleys are referred to as the gullet of the teeth. And these spaces help clear the material or the fibers out of the way as you move across the surface of those materials. And in this case, those teeth are set up with what are called alternating bevels. So there's beveled edges sharpened on these two sides, then there's beveled edges sharpened on these two sides. So those alternating bevels on the edge of this allow for room for those fibers to be cleared out of the way as you create that cut path, which we refer to as the kerf. Most hand saws only cut on the forward stroke, but blades like this saw and like this bow saw cut on both the forward and the backward stroke as we cut through those materials. So let's look at a couple other styles of saws here. We have here what's called a back saw, and this is used for cross-cutting materials. This rigid back intersects with what's called a miter box that can shift around and allow you to cut precision mitered or angled cuts through the cross-section of material. So we get the rigidity from the spine on the back of this saw. And then because it's a cross-cut saw, you can see that the teeth are very closely spaced and the set of the teeth is fairly minimal, so that, again, as we cut through or cross those fibers, it's less likely to tear those fibers out. And because it's rigid, it's able to hold a straight line as it moves down through that material instead of flexing or moving out of position. Keyhole saws, on the other hand, are very flexible, and they allow you to lance through an opening or go into a hole and then cut out openings where you're not so concerned about whether or not the blade has some flex to it or not. And here you see a little handle that is designed to be able to accommodate the change of different types of reciprocating saw blades. And the reciprocating saws, a saw we'll look at when we get into electric powered tools and cordless tools. But the reciprocating saw blade on this allows for cutting on the back stroke. You can see the teeth only face back, so forward and then draw back, and it cuts or clears those particles out. So again, this could be used to pierce or lance through, and the distance from the back of the blade to the teeth of the blade determines how tight a radius you're able to turn. The greater the distance between the back and the teeth, the less of a radius it's able to achieve. And the narrower the blade from the teeth to the back, the tighter a radius you're able to achieve. When it comes to cutting a really tight radius in materials, coping saws are particularly useful because the distance from the back to the teeth is very short. So again, that allows you to either come into an existing hole by taking the blade off and feeding through that hole, right? And the blade can be oriented so that the forward-facing teeth can be set up to cut on the forward stroke, or more typically face backwards so that it's cutting on the pull stroke. Coping saws used to be used a lot for a technique that is called coping. And coping is where we're following a contour along an edge so that we can get two pieces of material to match up in their profile. And this was most commonly done in trim work for installing baseboards and crown molding and things like that. And so, last but not least, we have this other pruning saw, which cuts on both the forward and the backward stroke. And each of these saws typically has a recommendation in terms of the thickest cross-section of material that they can efficiently cut through. And this particular pole saw gets mounted onto a long extension pole so you could reach up into a tree and cut sections off that were out of your reach. So we have key saws, we have ripping saws that strip out those fibers with chisel-like teeth. The frequency of the occurrence of teeth depends on the thickness of the cross-section that's intended to go through, but typically there is somewhere around 6 to 8 teeth per inch for most ripping saws. Cross-cut saws are going to have much finer orientation of those teeth, and a typical cross-cut saw might have teeth that vary from 10 teeth per inch to as many as 24 teeth per inch. Pole saws like this also include a range of saws that are generically referred to as Japanese or nokogiri saws that are very popular among woodworkers. And we already looked at the back saw and talked about that. That's typically used with a miter box. And then again, back to the bow saw, which is typically engineered for cutting through limbs that are up to 6 inches in diameter. And again, those usually have a very coarse tooth set that cuts on both strokes, the forward and the backward stroke, and usually somewhere around four teeth per inch. So let's get in and demonstrate. Before we jump in to demonstrate how to actually use these saws, I want you to also understand that there are tools that are specifically designed for resharpening saws, and that is actually another tooth cutting system. Files, just like saws, have teeth that present themselves in a very specific direction, and so files can be used to resharpen blades. And then there are devices like this saw vise that can be used to secure the saw blade in place for filing those teeth. And then this tool is a tooth setting tool so that if the set of the teeth get flattened out from wear, they can be pushed back out or reoriented by using a tool like this that you move along the body of the saw and push those teeth in opposing directions. And there's actually a little dial on here that allows you to set this up for different numbers of teeth per inch. So I don't know that you ever find yourself in a position where you need to do that, but I like the idea of knowing and understanding that it is something that can be done. Oh, and last but not least, let me just share these two little cuties with you. This is a little, you would call it a miniature model of a two-person saw where one person holds on one end and one person holds on the other end for cutting through large cross sections of logs. And then I have this homage to one of my mentors, Steve Meyer, who inspired me to make these handsome little model hand saws to give away as gifts to friends. So let's get into demonstrating some of the cuts that are made with these tools. Choosing the right saw to accomplish whatever you're trying to do is going to begin with the material. So the material type, whether that be hardwood or softwood, the thickness of that material, and its orientation relative to the blade. So when I say that, I mean this orientation as opposed to this orientation. So when we're in this position, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 9 to 10 teeth in contact with the cross section of those fibers. And when we're in this orientation, we have about 2 teeth in contact with that material. And remember, the minimum number of teeth that have to be in contact with that material should be a minimum of 2 to 3 teeth in contact with that cross section. I also need to think about the kind of cut. Is it going to be a straight cut that I want to maintain, a straight line? or is it going to be a curved cut? Because the height, or what's referred to as the width of that blade, is going to determine how straight it will stay, or how much of a curve it's capable of achieving. And so when we talk about what kind of saw, we're counting the number of teeth per inch, the type of set to those teeth, because remember, the set of teeth is different for different types of materials and for different types of cuts. Rip cuts like to have one type of set, and cross cuts like to have another type of set. We're also thinking a little bit about the alloy that blade is made out of, and we'll go into more detail about alloys when we talk about cutting metal, but carbon steel is the most common alloy that's used for woodworking saws. And we also need to consider that the thickness of that blade, the thickness of the cross-section of the blade, and the offset of those teeth of the blade will determine how much material is consumed in the process of making that cut. And that space is referred to as the kerf of the blade. So I'm going to gently just drag my saw backwards very gently to establish my cut path. And you can already see that it's having a tendency to really fur or tear those fibers up because the blade is so coarse. And the board is really bouncing because the blade is bouncing over those fibers and tearing and grabbing those fibers on in a way that is really it's ripping out the backside of that cut. So the first thing we're going to do is we're going to go ahead and change that orientation so that we have more material in contact with more teeth. So let's drop this guy down and secure that in place. And we'll give it a go with this alternate orientation. You see the way that it ripped out those fibers on the bottom of the cut? There's a number of different ways to address that, but even with that cross-section laid down with that wider surface area, the teeth were so coarse on that blade that it really did just shred those fibers as it exited that material. And that tear out, that's objectionable, and there's a number of different ways we can address that. But let's look at the opposite extreme where we're using a really fine-tooth back saw like this. And so the trade-off here is that it's a very stiff, rigid blade. It'll hold a straight line. It's less prone to tearing out those fibers. So I'm going to draw back and establish my path. Remember, these cut on the forward stroke, but I can draw back to establish that path. Still a little bit of tear out, but you can see significantly less tear out. So you can see super shaggy with that coarse blade, lots of aggressive tear out, and much less or a minimal amount on the backside of this. We could also address this tear out by cutting most of the way through and then flipping the board and doing a relief cut on the backside, again, to minimize that tearing. So our back saw really excels at holding that straight line. And you can see we're able to get a relatively straight, clean cut through the cross section of that material because of the rigidity of that blade. But it really is only good for making straight cuts because this distance restricts or limits its ability to move to make curve cuts. But all that can be solved by using something like a coping saw, which is actually engineered or designed to be able to make those curve cuts. So even if I'm establishing a curve cut, I'm most generally always going to start out by scoring this line at 90 degrees to establish my cut path. And then once that's established, then I can lay my saw over onto its side. And again, a very fine-toothed blade, which means that I have less tear out. But the downside is that it takes a lot longer to get through that material, and it's less likely to be able to maintain a straight line or a parallel relationship with that edge as you walk that around the corner. But its ability to make tighter turns is proportional to the distance between the teeth and the back of that blade. Again, the other advantage of coping saws is that it's very quick and easy to remove the blade from that coping saw and by turning the handle counterclockwise and swap it out to alternate blades. They have pins on the end which hold them in place. That would also allow me to be able to drill a hole through my material and then insert that blade through the hole to make interior cuts. Or I can also set my blade up so that the teeth are either cutting on the forward stroke or reverse it so that it's cutting on the back stroke. You may have noticed from our last two cuts that the tear out on material is always worse when the blade is exiting that material because it breaks away those fibers before they have a chance to be cut through clean. Another way to address that is by scoring the backside of your cut with a utility knife in advance to break those fibers so that they don't rip out. And this is also very useful to do when you're working on materials like plywood that have a fine veneer on the surface that you don't want to rip up and make all shaggy. And again, very easily done by simply taking a straight edge, or I've got a speed square, scoring a line on the back side of the surface of your material so that when you cut through, it's less prone to tearing that material. You can also take a layer of tape and put it down on the surface. So if you're using a fine-tooth blade and that tape is burnished down onto the surface of that material, as the blade exits, the tape will provide some support for those fibers. So, just to review what we've gone through, I really didn't have a proper ripping or crosscut saw that is typically come in 24-inch lengths available to demonstrate, but I think we got a good sense of, or understanding of, how important it is to consider the frequency of the occurrence of the teeth on a saw blade in relation to the thickness of the cross-section of the material. So this was an unconventional use for a big saw like this that would really be used for going through thick cross-sections of material. And I think that it's also important to note that although this miter back saw did a good job at making the cut we did, these are most typically used in what's called a miter box. That's either a wooden box that has pre-cut slots and a backstop that this would fit into and act as a guide to keep it straight, or there are fancier versions of these miter boxes that are fabricated out of metal that allow you to lock into preset positions of the most commonly used miter cuts, like 90s, 45s, and 22.5s. So that's the short of it for hand saws with wood. I look forward to working on the next module, which will be to go into some hand saws that are used for metal cutting systems. So until then, thanks so much for participating.